Okay, this is the Dilution of Gravity lab. We want to make sure that you're set up and ready to go. We are going to do lab groups, and so you can see that I have the lab groups assigned here. These are based off of what you told me, people that you thought you could work with, and then it's a mix of people within the group. So some of you will be in the room, some of you will be out of the room. Those of you that are in the room are going to be responsible for doing some of the data collection, and it can happen over 2 days. So if we need to, we might need 2 days to collect that data. So there's how we're going to set it up. You will be seeing how to set up 2 different sheets, a sheet and a doc to work with. When it comes to the lab report itself, we need to make sure that there are 3 distinct sections for it, and there's a rubric that's kind of set up to go through that process. So the first section is going to be your introduction and process. So give me the background, what's the goal of the lab, what's the science concept that's supporting the way of getting to the end answer, and then do you have a prediction of what you'll be able to see in the end. Okay, so that's our first section. The second section is all of our data analysis. So this is your data table that you're going to have. You're going to make sure that units are stated and we're reflecting our correct number of significant figures. Make sure that your graphs are labeled correctly. We're going to include trend lines into this because we're going to have to find the slope of some information. And then each person is going to write their own conclusion. So you want to make sure that you're writing a conclusion as well. And you can see what the points are. We always look at it with the lens of a English teacher as well. So we want to make sure the mechanics are good and the layout is good. There should be 2 pictures of the report of the setup or of the data collection that's in there as well. So we do want to make sure that we have graphics included in here outside of just the graph that we're going to use. So that's the rubric. And again, when we get through and we set this up, we're going to talk a little bit about the lab itself. So Galileo was the one who first tried to figure out what this acceleration of gravity was. We didn't know necessarily how gravity was doing this or why gravity was doing this, but we were able to figure out that the speed changed when a ball rolled down a ramp. And so as we changed the angle, we saw that we were approaching some kind of a limit. And so this is what Galileo was trying to do, and he was using some trigonometry to do this in. You're going to make sure that your group collects 5 data points, and I just want to show this diagram as well. So again, gravity acts straight down. So if this line here were to represent the value of gravity, this line right here would represent the acceleration going down the ramp. And you can see that from a triangle point of view, this side is shorter than this side, this being the hypotenuse. If we could build a relationship between this triangle right here, we'd be able to then figure out what gravity is. And so this angle right here has to be related back to this angle of the ramp. And so now we have that the angle of the ramp versus that acceleration down the ramp, this is the side opposite of the angle, and this is the hypotenuse. So this is a sine relationship. So the sine of theta, sine of the angle of the ramp, is equal to the acceleration over gravity. Now, if we go through and we look at that, we can then figure out that gravity is no more than a over sine of theta, which is like a slope. So if you graph sine of theta on the x-axis and a on the y-axis, and you find the slope of that, you'll figure out what gravity is. Now, we do have an expected value. This is the expected value for our altitude here in Buffalo. So that's the target value. When you do get your value, you'll probably average your, you're going to have your slope. Your slope should be compared to this through like a percentage error. So we'll do a little bit of percentage error as well in the end. So hopefully you kind of went through and watched all the video for the data collection and the setup and everything, and you'll be well on your way to doing this lab. All right, thank you.
All right, this is the data collection for the Dilution of Gravity lab. So what we're doing is we're setting up a ramp, and we're going to use books to prop it up. Now we're going to vary the amount of books to vary the ramp height. So that's going to be the key thing is that we want to see how the angle changes with, or how the acceleration down the ramp changes with respect to the angle because that graph should give us a value that's going to let us figure out what gravity is. So the angle is going to be an important feature. So like right now I've got a stack of books here. You're going to vary that stack of books so that you can get at least 5 data points. I'm going to use my little angle indicator here to try to measure that angle. And so I'm going to make sure that I'm reading it to the proper number of significant figures. You can see that I have a line for every degree. So I'm like, looks like I'm going to make my guess in the 10th of a degree. So I'm about 10 point, I don't know, 3. Okay, I go a little bit more, so let's see if I can zoom in here. So I'm in between 11, so I'm going to go 10.3 for that angle. Okay, so that's what I'm going to record as an angle measure. Okay, now we got to go through, and you can see that we've got photo gates set up here, and that these are going to be connected to our LabQuest Mini, which now needs to be plugged into a USB port. Okay, so once we have that plugged in, we can go ahead and open up Logger Pro, and we'll see what that gives us. But once it's plugged in and has power, we want to double check so that on our cart, this part of the gate goes through. So we're going to try to limit the distance that goes through the photo gate. So the photo gate works by sending a little beam through these openings there. So that's the gate that we're talking about, and you can see that the light's going to light up right there. So that gate's a good gate, and we'll just double check this one. Okay, and that's also a good gate, so it's set up. So in other words, as the cart goes down, this little distance here is going to go through this gate, and that's going to do a timing for us so that we'll get as good of an instantaneous velocity at this point as we can. And then it'll travel through here and give us another instantaneous velocity right here. And the gates will give us like a time between the gates. So from a kinematic point of view, we have velocity 1, velocity 2, time between the gates. And that's what we'll use to then figure out the acceleration down the ramp. Now you can see the Logger Pro set us up with some graphs. And really we don't need the graphs, so I'm just going to get rid of those. So I'm just making sure that when I click on it, I get the little boxes, and I can press delete, and I can get rid of it. Make sure that we don't get anything else to pop up. Let's see. Oops. There we go. Let's get rid of this one. And then we'll get rid of this one. Okay. Now, the table is what I'm going to be concerned with, so I'm going to go up here to Page, and this is a nice feature here in Logger Pro. Go down to Auto Arrange, lets me find everything again. So now all I have to do is click Collect, and the gates are now ready to start timing. So I'm going to go ahead and let this gate run through. And catch it there, and let's see what our computer told us here. So we have times now. That 8 seconds that you see there is the time that it took. Oh, I should stop it. Okay, that's the time it took me to get the gate, or the cart started going through the gate. And so then what we'll have is 4 times. So my recommendation is that the data collector actually take a picture of this and get the angle, so that they can then collect all 5 data points, so that you can then work with your team with that data. Now the first time, okay, represented the time that this gate started timing on this side. The second time is the time there on this side. So the difference between those 2 times represents the time in the gate. So these first 2 numbers are going to represent the time in the gate. You can see that the state of the gate was started, stopped. Okay. The same thing happens with the next 4. We have a start and a stop, and so the difference between those is going to represent the time in this gate. Okay. Now to get the time between the gates, we're going to use the first 2 points. So when we started this gate and when we started this gate. So 1 and 3, we do the difference between those, and that would give us the time between the gates. So we'll have 4 data points, or 4 times that we're going to enter into a spreadsheet, and then we'll set it up to do some math to figure out all of the others. And I'll show that here in a second.
Okay, so now we're back working on our computer. This is one that you don't have any documents that pop up in Google Classroom. So you're going to have to go ahead and create a doc. So this is going to be where your lab report is. And then I would also recommend creating a spreadsheet. Okay, so the first one is going to be your lab report. So you can go ahead and title this one Dilution Gravity. Okay, and then make sure that you put on your report your title, your names, and then you're going to make sure that this one gets shared with not just the people in your group, but share it with me as well. Okay, because this is the one that I grade. All right. Now, with the spreadsheet you don't have to share with me because you're going to take the information from there and put it into the document. But you may want to write or title this one as well, so that you as a group know, so you'll share it with your group members. Now what I will do is we're going to start here. That first piece of information that we collected was our angle. Okay, and the angle was in degrees. And I think I said it was 10.3, so I'm going to make sure that I have my angle listed. But then I'm going to have times, okay? So I'm going to do this is going to be time in gate A, time out gate A, time in gate B, and time out gate B. Okay, so these are the numbers that are going to come from that picture. I just got to pull my picture up off of my phone, and I'm going to type those numbers in. So 8.048529. So that's that first one. The next one was 8.07. 750. The next one was 8.501653, and the next one 8.5167776. Okay, and so those are going to be my times. So when I go over here, I'm going to calculate. This is time in A in seconds. This will be time in B I'm just going to put gate B time gate A. Okay, so to do that calculation, we're going to start with an equal sign, and we're just going to take the time out of A minus the time in A, and that'll give us the time that was gate A. We'll do the same thing for gate B. So it's going to be out minus our in, and that'll give us that time. Now to get our velocities, okay, we need to know what the width of that piece of gate was, or the fencing was. So this is fence lay. And you'll need to measure that, okay, so that's something that has to be measured in the lab. I think if I'm just going to put in a number for right now. I'm going to put in 2.50 centimeters. Okay, so that's going to be my centimeters. So now I'm going to find my velocity, and this will be in centimeters per second. Okay, and this is going to be velocity of A. And that'll be equal to the fence length divided by the time in A, and that's going to be pretty darn close to my instantaneous velocity. Now, I'll probably need to adjust this for my significant figures. So like this column right here should have an extra 0, so I should have been able to measure that out. So that's 3. The times are going to be a lot, so really we're going to just keep this at about 3. Okay, and then we'll do the same thing for velocity v. Again, in centimeters per second. Okay, and this will be equal to that same fence length divided by the time in B. And I'll adjust this one as well. And you can see that velocity at A was smaller than velocity at B because we were gaining some of that in there. Okay, and then we'll be able to use, we'll have to get our time between. And this will be in seconds. And so this will be that first time, or the time in B, minus the time in A. Okay, so now we have the time between the gates. So again, these 3 columns right here are going to be what we'll use kinematically to figure out the acceleration down the ramp. So this will be our ramp acceleration, and that'll be in centimeters per second per second. If you ever want to, you can always wrap information. So I'm just going to show formatting, text wrapping, wrap. So I'll just wrap that. And that makes it a little bit bigger instead of always just adjusting. But that's going to be then a kinematic relationship between these 3 columns. So this is a calculated value. Once you have your angle and your ramp acceleration, that's going to go into figuring out a graph that we'll want to find the slope of. So angle on the x-axis, ramp acceleration on the y-axis. Now when you do get graphs, okay, or if you want to take a data table from here, you can just copy those and paste those directly into a document. So like if I do insert and I can go from, I want to do an insert a chart, I can insert the chart from sheets, and so I find that sheet that I'm looking at to use. Okay, so someplace over here I'm going to select, and then it'll say, well, I need to have a chart. So when the chart's done, I'll be able to do that. And if I wanted to get a data table, I could collect those values from my data table as well. So, oh, hold on, there we go. So if I want to collect my raw data, so this is the raw data that I collected, I can just do a copy, go ahead and then do a paste. Okay, and I'm going to paste link to the spreadsheet, okay, so that it's going to be directly linked back. So again, you don't have to share the spreadsheet with me. The only thing that you have to share with me is this document, which is going to be your lab report. And you'll have 3 sections to it. So that introduction section, the data and analysis section, and then your conclusions. And remember, everybody writes their own conclusion. All right? Hopefully this helps get you started.